Hi, it's Mrs. Pope, and today we're going to be talking about solving quadratic equations. Our goal is to graph them, quadratics, to estimate solutions and solve equations. So not only are we going to solve them, we're also going to be able to look at a graph and look at a table and estimate our solutions if we can't find them exactly. Vocab here, roots. These are the solutions to the quadratic equation, so the solutions that make it true when it's set equal to 0. And the zeros are where the graph crosses the x-axis. So here you see our parabola, and this is a graph of a quadratic, and where it crosses the x-axis, these are called solutions, zeros, and roots. They're used interchangeably, and you'll hear them all the time. So just understand those are the same exact thing. Solutions, zeros, and roots. All right. So first, let's look at the three possibilities, the possible solutions for a quadratic function. One thing you could have is no real solutions. So a graph may look something like this. Here's the parabola. There are no real solutions because it never crosses the x-axis. The other option you may have is one real solution. So if we had one real solution, maybe it'll look like this. It'll only touch at one specific point. It touches and goes right back up. And because it touches the x-axis one time, there's one real solution. And the other most common one that we see would be two real solutions. This is where it crosses the axis two times. So overall, however many times it touches the x-axis, that's how many solutions, or zeros, or roots there are. And remember, these terms are used interchangeably. All right, let's look at an example. Example 1. No real solutions. So this one I'm telling you right ahead. There aren't going to be any solutions. So let's see what that looks like graphically. If we were to solve negative x squared plus 15x minus 63 is equal to 0, so that means we're solving this. We want to find out when this is actually equal to 0. By graphing, that means we want to find out when it crosses the x-axis, because that's when the function y would be equal to 0. So find the axis of symmetry. That's the first thing that we do. So remember, A is equal to negative 1, B is equal to 15, C is equal to negative 63. So we want to find negative B over 2A, or negative 15, over 2 times negative 1, which would be negative 15 over negative 2, which would of course be positive 7.5. So I found my axis of symmetry, the x value of my vertex. And if you remember from before, the reason we want to find this first is so we can get an idea of what numbers we should choose for our table. Now I'm going to let you finish this table on your own because we've done some like this already. But what you'll notice I've put in is the vertex. So the x value is 7.5, which I got from here. And if you plug that in, you'll get negative 6.75, and that's my vertex. I've graphed it here. And I'd like you to fill the rest of this in, but I do have the ordered pairs, which I've already graphed here, just to show you how it's going to look, just to have a sketch. Well, I don't need any more points to figure out that there are not going to be any more solutions. There are no solutions to this, because this graph is going to continue going down. It has a maximum here, so it will never ever cross the x-axis. So any graph that doesn't cross the x-axis does not have any solutions. So there's what that would look like. Example 2, let's look at two real solutions. So here's our equation, and we want to graph it. Now, if we find the axis of symmetry, x equals negative b over 2a, so x equals, b is negative 3, so positive 3 over 2 times 1, which would be 3 over 2, which would be 1.5. Now notice, I've already put in 1.5 for x. I get out negative 6.25. That's my vertex. What I want you to do is to finish this table. Finish this table, find your y's, find your ordered pairs, and then I want you to plot them. From that, if you do it correctly, you should easily be able to see the solutions, and that's what I'll be looking for in your notes. Notice, I've already given you the vertex, so at least there is 1 point you already have. All right, example 3, estimate solutions. Often, exact roots cannot be found by graphing. It's nice when you can graph and they cross the x-axis at a wonderful point and it's very easy to find. That doesn't always happen. So instead, what happens oftentimes, maybe here's your table. This is a condensed version of the longer table we're doing, just the x's and the y's. Well, if you look here, I have my x values and my y values. We can look at the table to kind of estimate where the zeros are going to be. So I notice my graph is positive at 0. The y value is positive. Then I jump to negative. So somewhere here, it had to cross the x-axis or it wouldn't go to negative. So somewhere in here, in between there, one of the solutions is here. Then I look, my graph is below, because it's negative, 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 negative. Uh-oh. Then it jumps back to positive, which means it had to cross the x-axis again. So somewhere in here is the second solution. So solution 1 is somewhere between 0 and 1. We can just look at the table and tell that. And our solution 2 is somewhere between 5 and 6. So just by looking at a table, you can kind of get an idea of where these solutions will be. So your answer is going to be somewhere between 0 and 1, some kind of decimal. And here, the other one is going to be somewhere between 5 and 6. That allows you to just get a broad estimate of where the zeros are going to be. So if you had something here, you know there's going to be a 0 somewhere here, 2, 3, 4, 5, 6, 7, and somewhere between 5 and 6. 1, 2, 3, 4, 5, and 6. Somewhere between there. I know that it's opening up because it's positive. I don't know the vertex yet. I could find that if I wanted to be more exact. But I can kind of tell it's going to look something like that. It may have gone lower, maybe up higher, but this is just to give you an idea, a rough estimate of what your graph should look like. So remember, here's our hint. Look for the change from positive to negative, or vice versa, negative to positive, in the y values, and that'll tell you where your solution lies. Thanks for watching, and remember, you are responsible for your own learning.